Okay, this is the tangent lines practice. So we did 1 through 10. So we're assuming that the line, if the line appears to be tangent, it's a tangent line. C is the center of each circle. Find the value of x. So number 1 here, we're going to use the first theorem from our notes, which says that if we have a tangent line and a radius that intersect, that intersection is going to those lines are going to be perpendicular, which means they're going to form right angles. So here we have a radius. Here we have a tangent line. Therefore, they're perpendicular, which means this angle here is 90 degrees. It's a right angle. We know by the triangle sum theorem that the three angles of a triangle add up to 180. So this is 90, 58, and x, and they're going to add up to 180. So it's going to be 148 plus x equals 180. Subtract 148. I'm going to get x equals 32 degrees. 32 plus 58 plus 90. Okay. Number 2, again, we're using the same theorem. We have tangent lines, 2 tangent lines here. Here's the second tangent line. And those tangent lines are going to be perpendicular to the radius, the radii, radiuses. I think both are acceptable. Okay, but we have a tangent line and a radius, so this is going to be a right angle. Tangent line and a radius, so that's going to be a right angle. So we have a quadrilateral. It's got 4 sides. We know the 4 angles of a quadrilateral add up to 360. So we have 90 plus 130 plus 90 plus x equals 360. Okay, 90 plus 130 is 220. 220 plus 90 is 310. We subtract 310 from both sides. We get x equals 50. Okay. 50 degrees. Scroll down to number 3 and 4. So they're telling us AB is tangent to circle C at point B. So AB is our tangent line, B is the point of tangency, and it's all on circle C. Find the value of x. Okay, so here's our tangent line and a radius, right? So again, that first theorem is telling us when we have a tangent line that intersects a radius, they're going to be perpendicular, which means they're going to form a right angle. So we have now have a right triangle. If the radius and the tangent line are perpendicular, that means they form a right angle. They form a right angle. You have a right triangle. If you have a right triangle, we can use the Pythagorean theorem. We can use a squared plus b squared equals c squared. The legs of our right triangle are x and 8. So we have x squared plus 8 squared equals the hypotenuse squared. The hypotenuse is going to be x plus 2 squared. So again, if I were to redraw this triangle, this would be x, this would be 8, and this would be x plus 2. So we have x squared plus 8 squared equals x plus 2 squared. So that's x squared plus 64. This x plus 2 squared is really the same as x plus 2 times x plus 2. Okay, so we can have x squared plus 64. We can FOIL this out. So first, x times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. First, outer inner, last. Yeah. So combined like terms, we're going to have x squared plus 64 equals x squared plus 4x plus 4. We can subtract x squared from both sides. We're left with 64 equals 4x plus 4. We can subtract 4. 60 equals 4x divided by 4. And we get 15 equals x. X squared plus 8 squared equals x plus 2 squared. From there, it's just algebra. Okay, we really could have just gotten, once you hear, you can get everything on one side. And you can use menu 3 in the calculator if you want. Okay, I'm going to delete this so we can look at number 4. Well, no, that's fine. Let's just do a different color. Okay, so here we have AB, tangent line, radius CB. So they're perpendicular, which means they form a right angle. Okay. If they form a right angle, it's a right triangle. If it's a right triangle, we can use the Pythagorean theorem. A squared plus B squared equals C squared. Okay, the other trick to this problem is finding what BC is. So BC is a radius. So all the radiuses are the same. So this radius right here is 3, which means BC is also going to be 3, because it's also a radius. So again, we have a right angle because it's a tangent line and a radius. So we have a right triangle. So we can use a squared plus b squared equals c squared. The legs of our triangle are going to be, again, the legs are adjacent to the right angle. So that's going to be x and 3 and x. The hypotenuse, so here's the 2 legs. The hypotenuse is this whole length here, okay, which is going to be 3 plus 7, which is 10. Right, if I redraw this triangle, this is 3, this is x, and this is going to be 10. Right, because 3 plus 7 is 10. So we have x squared plus 9 equals 100. We subtract 9 from both sides. X squared is 91. To get rid of the square, we have to take the square root. So x is going to be square root of 91. We can leave it like that, or we can find the decimal. Either one will work. Okay. Same thing, really. Not much different for 5 and 6. We want to find the value of the radius, r. Okay. So again, we have a tangent line and a radius, so it's a right angle. The legs of this right triangle are going to be r and 4. So again, we want to do a squared plus b squared equals c squared. So a is going to be r squared plus 4 squared, right? Because a and b are the ones that are adjacent to the right angle. So if we redraw this triangle over here, this is 4, this is r, and this is r plus 2. So r squared plus 4 squared is going to equal r plus 2 squared. Four squared is 16. This is really r plus 2 times r plus 2. So first is r squared, outer is 2r, inner is 2r, and last is 4. So we have r squared plus 16 equals r squared plus 4r plus 4. Okay, we subtract r squared from both sides. Those cancel. We get 16 equals 4r plus 4. If we subtract 4 from both sides, okay, we're going to get 12 equals 4r. Then we can divide by 4, and we get 3 equals r. From which 3, 4, 5. So that'll work. Let's go to number 5. So same thing here. Tangent line radius. So here's our right angle. Means we now have a right triangle. R and 12 are going to be the legs. R plus 8 is going to be the hypotenuse. So in our formula for a squared plus b squared equals c squared, we're going to have r squared plus 12 squared, r squared plus 12 squared. Those are the legs, and then the hypotenuse is r plus 8. So that's r plus 8 squared. So r squared plus 144 is going to equal r plus 8 times r plus 8. R squared plus 144 r squared. So first, r times r is r squared. R times 8 is plus 8r. Inner plus 8r. And then 8 times 8 is 64. So we have r squared plus 144. Combine like terms, r squared plus 16r plus 64. Subtract r squared. We get 144 equals 16r plus 64. We subtract 64 from both sides. We get 80 equals 16r. We divide by 16. And we get 5 equals. Okay. So 3, 4, 5, and 6 all the same. We're basically using the first theorem, which tells us that the tangent line is perpendicular to the radius, so those are right angles. Then since we have a right angle, we have right triangles, and if we have right triangles, we can use a squared plus b squared equals c squared, the Pythagorean theorem. Okay. 7 and 8 asks us, are the lines tangent? So to determine if the lines are tangent, we're going to need to show that we have perpendicular lines. So to show that AB is a tangent line, we need to show that we have a right angle here. This is what we're trying to show. Okay. Because in order to show that it's a tangent line, we know by the first theorem that it's going to be perpendicular with the radius. So if it's perpendicular with the radius, it's going to form a right angle with the radius. Angle CAB is going to be a right angle. So if it's a right angle, that means you have a right triangle. If you have a right triangle, a squared plus b squared is going to equal c squared. So what we're going to do to figure this out is we're going to look at the triangle and see if it's a right triangle. So is a squared plus b squared equal to c squared? Okay. This is the angle we're trying to determine if it's a right angle at. So the legs of that hypothetical triangle would be 5 and 15. So we would have 5 squared plus 15 squared. And the hypotenuse of that hypothetical triangle would be 17. 5 squared is 25. 15 squared is 225. 17 squared is 289. Okay, that's going to give us 250 equals 289. That is not a true statement. 250 does not equal 289. What that tells us is that this 5, 15, and 17 do not form a right triangle. Okay, because a squared plus b squared equals c squared only works for right triangles. So that's telling us that this triangle is not a right triangle. So if that triangle is not a right triangle, that's not a right angle. If that's not a right angle, then our line here, AB, and the radius are not perpendicular. If the line is not perpendicular to the radius, then that line is not going to be a tangent line. So AB is not a tangent line, no. If it were a tangent line, it would be perpendicular, meaning it would be a right angle, which also means it would be a right triangle, and a squared plus b squared would equal c squared. But we found that a squared plus b squared does not equal c squared, so it's not a right triangle. There's not a right angle at angle A. It's not going to be perpendicular. The radius and the line aren't perpendicular, therefore it's not going to be a tangent line. Okay, number 8. Oops. Same thing, is AB a tangent line? We have to do the same thing. We have to use the Pythagorean Theorem and see if a squared plus b squared equals c squared or not. So is a squared plus b squared equal to c squared? Again, this would be the angle in question, so the legs for that triangle are 5 and 14. So does 5 squared plus 14 squared equal 15 squared? 5 squared is 25. 14 squared is 196. Right? I think. Pretty sure. Yeah. 25 plus 196 is going to give us 221. 221 does not equal 225. So again, this is going to be no, not AB. Line AB is not a tangent line. If line AB was a tangent line, then a squared plus b squared would equal c squared. And this would be a right triangle. And you'd have a right angle and you'd have perpendicular lines. But since it's not a right triangle, it's not a right angle. And since it's not a right angle, the radius and the tangent line are not perpendicular. So it's not going to be a tangent. Okay, last two we're going to do are 9 and 10. Probably zoom out a little here. Okay. 9 and 10, we're utilizing the second theorem. Okay, the second theorem says that if you have two segments that are tangent to the circle and meet at an exterior point, those segments are going to be congruent. So basically, if you have two tangent lines, line CB and line AB, okay, and if they meet at a point at exterior to the circle, so outside of the circle, and they meet at a point outside the circle, they meet at point B. If those are two tangent lines that meet at an exterior point, then the segments from the point of tangency to that exterior point will be congruent. Okay, so these two will be congruent. AB and CB will be congruent. Meaning AB equals CB, AB is 15, CB is X. So we know X is going to be 15. Two segments are tangent to the same circle and meet at an exterior point, meaning a point outside of the circle, then they're going to be congruent. The same size and shape, same length. Okay, same thing for 10. We have two tangent lines, right? It's telling us they're tangent lines. They meet at a point exterior to the circle, outside of the circle. Point B is outside of the circle, so it's exterior. So you have two tangent lines that meet at a point outside of the circle. So those segments are congruent. AB, again, is congruent to CB. So AB equals CB. So X minus 24 equals 50. Solve for X, add 24 to both sides. We get X equals 74. And that's all we had to do. I don't think we're going to ever get to 11 through 15. So I think we're good on that assignment.